Hello everyone, welcome to this video, and today we are going to solve a question of hypothesis testing. Alright, and we are going to solve this question in a very detailed way so that you don't get confused in any of the parts during your examinations or any other sort of tests or even questions that you further do during your practice. So at first, we are given the mean density of the steel supplied, which is often represented by the letter mu, as 7850. Then you are given the standard deviation of the population sigma as 250 kg meter cube. Of course, it's kg meter cube. And then from this is the data of the population, right? This is the data of the population. Then in the second instance, they have given you the sample mean x bar, which is given by 7900 kg per meter cube. This is the sample mean. This was the population mean. This is a sample mean. And now the question 7900, that is the sample mean or the mean density of the sample, all right? And the number of sample is given, that is n is equals to 50. So this is the data about sample. Now the claim is that at first the company always sends the population, all right? So let's say the company is usually sending a steel of density 7850 kg meter cube with a standard deviation of 250 kg meter cube. Now suddenly the company claims that the strength of the steel has increased. All right, now the strength has increased. Company claims that the strength has increased, and so it sends out 50 samples to the retailer or whatever retail, and the person and the company tests it, the increased sample, and it finds out that the sample mean is 7900 kg per meter cube. Now, can we support this claim from the given sample, given that our significance level is 0.01? So now significance level actually gives you the confidence data, and from that you are able to compare it with the sample, and then you are able to tell whether you can assume that your sample mean, that your new data or new model of steel that you have just recently produced has increased its strength or not. So how do you do this? Well, you do this by the following methods. So first of all, we have step one. All right, so in step one, we always start with a hypothesis. So we have two kinds of hypothesis. The first is null hypothesis. All right, now I repeat, if you are watching this video, then you don't need to watch anything related to this type of questions because I'll explain everything. So null hypothesis is generally related to equating something with a given data. So let's say in null hypothesis, we assume that there is no change and the new mean or the sample mean is equal to 7850. That means now the sample that is produced later, that means the sample which is produced after the company has decided to increase the strength of the steel is 7850. That means the strength has not increased. So this is the null hypothesis, all right? And then we set the alternative hypothesis. This is the exact counterpart of null hypothesis. And in this, we assume that the strength of the steel has increased. That means the mean is greater than 7850. Now remember, many of the students confuse this with this data. This data is the sample mean. It does not necessarily mean that the new population of the steel that is produced has this average mean. It does not mean that. It means that you have a lot of steels in your warehouse. You take 50 of the steels from the warehouse, and then you check the average mean of their densities, and you found out the density 7900, and then the boss told you to now find out using probability that whether the company's new production has been successfully able to increase the strength of the steel. And then you set two hypotheses. First of all is null hypothesis, and in null hypothesis you said that the mean has not increased, so that means the previous mean is 7850. And alternate hypothesis, which is the claim, you assume that the strength of the steel has increased. Now the strength of the steel has increased means it can be any value greater than 7850, right? So that is it. Now when you set this hypothesis, the step 2 in this process will be to find out the value of Z. All right, to find out the value of Z. Also test whether your sample is greater than a threshold. So that threshold is 30. Remember that if your sample size is greater than 30, then use Z table. If your sample size is less than 30, then use T table. Alright, so now you can see here that our sample size is greater than 30, which is 50. So therefore, we are going to use Z table. Now, after we have decided this sample size, what we are going to do is we are going to calculate the value of Z from this given data. We know that the value of the Z is x bar minus mu divided by sigma by root under n. So this is the value of Z. Now we know that what is x bar? Well, x bar is the new, alright, is the new mean of the sample. The old mean is 7850. The standard deviation of the population, alright, wait 1 minute. The standard deviation of the population is 250 divided by root under 50. And when you compute it using calculator, right? Sorry, this is 7850. So 7900, I'm using calculator right now, and you also use it. 7850 and 250 divided by root under of 50 gives you 1.4. all right, so this is 1.41. This is the value of Z that you obtain. Now when you obtain the value of Z, the next thing that you need to do is calculate the significance level. So significance level, that's the alpha, is given by 1%, which is equal to 0.01. And the step 3, now the step 4. Now this is the most important step in this process, is to identify whether this kind of question, or this is a right tail test or two tail test, or one tail test or two tail test. So how do you identify whether it is two tailed or one tailed? So in order to do that, the first thing that you need to do is to look at the framing of the problem. If the problem states something like increased, decreased, or any other sort of increase and decrease, if your alternative hypothesis is increasing, has a condition of increase or decrease, then always your hypothesis or your question or your problem should be done with a two-tailed, should be done with a one-tailed test. All right, should be done with a one-tailed test. If your question has something like prove that the strength has increased, or if the question says prove that the density has changed, all right, or find out, support the claim, or test the claim that the strength has changed. So if something like change or that sort of stuff is given, all right, then that kind of thing is a two-tailed test. So this is all that we need to know in this part. Now, since this is a two-tailed test, then in two-tailed test, now I'd like you guys to generally look at what we are trying to do here, right? This value that you obtain here is the value of z. Alright, now you need to understand this graph very clearly. This is the normal distribution of the z table. The value that you have obtained is positive, that means it's in this part. This is 1.41. So this is the value that you obtain. Now you need to check whether your significance level, what is the value of z that you obtain from the significance level. So when you have alpha in the significance level that is equal to 0.01, that is the the alpha that you obtained, right? Since this is a right tail test, the alpha that you obtained is 0.01. So what you need to do is you need to subtract it with 1 minus alpha to get the area, or to get the area of the graph. And from the area of the graph, you need to calculate z. Alright, you need to calculate z. If this was left-tailed test by any form, then in that case you'd only write alpha, because z table you know is always a left side table. So that means whenever I calculate some value, let's say in z table I write 2.33, then let's say 2.33 is somewhere here, then the value from the z table indicates the area covered on the left side of the 2.33. So therefore this is the property of the z table, and if you understand that property, you know why we are doing 1 minus alpha, because since this is a right tail test and the area that you obtain here is 0.99. Now from the z table you need to find the value of 0.99, and the value of 0.99 from the z table will give you the value of z, and you need to check whether your value of z has exceeded 1.4 or is within 1.4. So let's say that you get this area. Alright, so this is the area. Now let's say the area is covered by the z value of 1.3. That means if I draw a line from here, and if I look at the area on the right, alright, if I look at the area on the right, then if I look at the area on the right, then this is 0.99. This is one instance, alright, this is one instance. But another thing is that in this case you can see that the 1.4 is after 1.3, alright, so it is lying in the alternative hypothesis region. Alright, so it is lying in the alternative hypothesis region. So therefore we can ensure that the null hypothesis is rejected and alternative hypothesis is accepted. But let's say that from this area 0.99 you get a z value somewhere around here, alright, somewhere around here. Then let's say you get 2.8, you get the z value 2.8, and in that particular case you should understand that this region, this line, this value of 1.4 is lying after 2.8. So therefore this is in the null hypothesis region, and so the alternative hypothesis is accepted. Sorry, alternative hypothesis is rejected and null hypothesis is accepted. So now we will do actually this question. So in order to do that, I would like you to look at 1 minus alpha, and now we want to go to the z table. Right, now we want to go to the z table. I'm opening z table. Okay, so I think we have got the z table in here. So this is the z table. Now we want to go at the right side, right? We want to go at the right side. So you can see here that this area is always represented on the left side. All right, but we have already done 1 minus alpha, so we don't need to worry about that. Now we want to check the value of 0.99 and what is the z score for it. So we'll search the value of 0.99 and we'll find the closest value to 0.99. So it's 97. You can see here that we have got 0.9901, all right, in here, and this is 98 and this is 04. So this lies in 2.3 and 0.3. So the value of z must be 2.33. All right, the value of z must be 2.33. So I will close this z table. Now the value of z must be 2.33. So from here we obtain the value of z, that is in this step is the value of z 1 minus alpha. From table we obtain the value of z to be 2.33. all right, that means you can now see from this graph. All right, I'd like to redraw the graph again. From our calculation we observe that the value of z is 1.41. this is from calculation. From table we obtained it is 2.33. so since this 1.41 is beside 2.33 here, then we know that this 1.41 lies in the null hypothesis region. So null hypothesis is accepted. So we move on to the final step, that is the step 5, and we say null hypothesis is accepted. Is accepted. All right, so that means the claim cannot be made. All right, the claim cannot be made. That means there is no significant increase in strength in the steel production. So now what you need to do is you need to recalibrate your machine. You need to make these products more better by employing other methods, and you need to find the error why your steel has no considerable increase in strength. So this is how you can calculate or estimate whether something is working properly or not from this Z table and from hypothesis testing. So this is all about hypothesis testing. All right, now I would like to add another thing. Here we have done one tail test. Let's say we frame the question in certain way that the claim is the strength has changed. All right, now we claim that the strength has changed. In this case we already know that when we draw such a claim, then in step 4 we are going for two-tailed test. Now what do we do in two-tailed test? So in two-tailed test we have this reason, and we will calculate the value of z by using the formula of significance 1 by z 1 minus alpha by 2. That means in previous case when it was right sided we only did 1 minus alpha, but in this case we will do 1 minus alpha by 2. So this will be 1 minus alpha is 0.01 divided by 2, and this will become z 0.995. Now we will open the z table and we will see the value of z using the z table. All right, so from the z table again, so I've got the z table here. Now we will see the value of 0.995 using the z table. All right, so 0.995 9925, we have 4 here, we have 57565 5553 5149. So it's 49 closer or 51 closer. So we have a kind of a draw situation over here, but we can take, since we have a draw, right, then we need to add up these two values. All right, then what you need to do is you need to calculate 2.57 and 2.58 and add up these two values and calculate the average. That's what you need to do. That means, what I mean to say is, look, if you get something like 0.995 from the Z table, you will always try to find out the closest number to 0.995. In this case, the closest number to 0.995 was 0.994 and 0.9951, because both of them exceed this 0.9951 exceeds 0.9951 by 1, and this also leaves or lacks 0.995 by 1. So therefore we have a tie over here. So in case of a tie, you take this number 2.57 and you take this number again 2.58 and you add them both and divide it by 2, and then you will get 2.575. 2.575. All right, you get that. So when you get this 2.575, all right, when you get this value, that is 2.575, now from the Z table you have 1.4 over here. From the Z table you have the value of the value that you obtained, right? The value that you obtained previously is 1.41. all right, the value that you obtained is 1.41, and then you get here 2.575. Then again you see that it is accepting null hypothesis. That means now the density has not changed, right? Now let's say the value that you obtain from Z be greater than 2.575. If it was somewhere here, then you would say that alternative hypothesis is accepted, and then we accept that there is a change in the strength of the steel. So this is how you do hypothesis testing using this particular data and this particular mean, right? So this is how you do hypothesis testing. I hope you understand completely what I was trying to convey, and hope to see you in the next video and practice more. Thank you very much.